The modern Thar Desert is defined by its extremes. Heat waves distort the horizon, and across thousands of square miles of burning sand, finding a single drop of water is a daily battle for survival. But this arid surface masks a different history. 30 meters beneath the dunes lies a graveyard of prehistoric marine predators. 167 million years ago, during the Middle Jurassic period, these coordinates were the floor of the Tethys Sea, a violent, deep water environment ruled by ancient sharks and marine crocodiles. The evidence is locked in the local sandstone. Recently, paleontologists in Jaisalmer uncovered the fossilized remains of Tharosaurus indicus, the oldest known diplodocid dinosaur on Earth. Nearby, at the Akko Wood Fossil Park, 180 million-year-old trees stand perfectly petrified by the pressure of that ancient ocean. Typically, when an ocean evaporates, it leaves behind rock flats, mud, and salt. It does not produce billions of tons of loose yellow sand. The material covering Rajasthan today had to be manufactured elsewhere and transported here by a different set of forces. This 3D cross-section models the tectonic shift that ended the Tethys Sea. As the Indian plate drifted north and collided with the Eurasian plate, the ocean floor was thrust upward, forcing the water to retreat and leaving the region exposed. The immediate result was a hamada, a landscape of cracked, barren stone and hard mountain plateaus. At this stage of history, the region contained no sand at all. However, that same collision simultaneously created the highest peaks on Earth. The rising Himalayas would provide the raw materials for the desert below. High in the mountains, glacial ice and roaring meltwater battered the fresh rock. This constant friction ground the heavy Himalayan stone into microscopic silt. Massive ancient river systems, including the Indus and its lost tributaries, acted as natural freight trains. They carried billions of tons of this crushed mountain rock downstream, spreading a thick layer of sediment across the plains of northwest India. While the rivers delivered the silt, they left it as a flat expanse of wet mud. To transform these deposits into a desert of rolling dunes, the landscape required a different geological tool. As the climate shifted, the ancient river systems dried up or diverted, leaving millions of tons of Himalayan sediment dehydrated and exposed. Fierce southwesterly winds began to act as bulldozers. They scooped up the dry silt, carried it southeast, and piled it against the rocky base of Rajasthan, creating the iconic sand dunes seen today. Every year, the Indian monsoon pours millions of gallons of water across the subcontinent. Under these conditions, the loose sand of the Thar should be washed back into the river systems and out to sea. The desert remains dry because of the unique placement of the Aravalli Mountains. Unlike mountain ranges that stand as a wall against weather systems, the Aravallis run parallel to the incoming monsoon winds. The range acts as a highway, channeling moisture-heavy clouds straight past the desert toward the north. Any rare moisture that does reach the dunes is quickly vaporized by the intense ground heat before it can penetrate the sand. The Thar functions as a closed loop. Its material was ground by the Himalayas, its structure was built by the wind, and its aridity is maintained by the geometry of the Aravallis. Surface observations missed a critical detail until satellite radar pierced 30 meters beneath the sand. It revealed the Ghaggar Hakra Paleochannel, the dried-up remains of a massive river system that once flowed through the heart of the desert. This river sustained the Harappan and Kalibangan civilizations. These early urban centers relied on its perennial flow to survive in an increasingly hostile environment. When water sources failed, Dhaulagira's inhabitants attempted to bypass the drought by carving 16 massive reservoirs out of solid rock to harvest seasonal rain. Even these advanced systems could not compensate for a shifting climate. As the rains finally stopped, the massive reservoirs emptied entirely, and the cities were abandoned, eventually buried by the advancing sand. A desert expands and contracts based on the strength of its natural barriers. If those barriers are compromised, the sand moves. In November 2025, a Supreme Court ruling restricted the legal definition of the Aravalli Mountains to hills standing over 100 meters tall. This removed legal protection from 90% of the range, opening the hills to industrial mining and real estate development. As hills are leveled, the natural windshield is failing. Choking dust storms from the Thar now blow through the gaps, directly into Delhi. History indicates that when a civilization dismantles its natural defenses, the environment reclaims the space. As the Aravallis are flattened, the buffer between the desert and the capital is thinning, leaving all our modern infrastructure completely vulnerable to the same forces that once buried the cities of the Indus Valley.